Good morning. Sorry I can't be with you today. So these are 5.4 notes, which you'll notice is on page 140 in your student journal. So make sure you're on page 140 in your student journal, and this is where you can write all this stuff down. Pause me, rewind me, play me again, do what you got to do to make sure that you are able to get all these notes down and that you understand them. Okay, so we're going to be looking at isosceles and equilateral triangles today. So this is a picture of an isosceles triangle, which if you remember, we know that we have two congruent sides in an isosceles triangle. Those two sides are called the legs. The side that's not congruent is called the base. And then you can see that the angle that's formed by the congruent sides is called your vertex angle, and the other two that are, alongside the base and formed by the base are called your base angles. So we have a couple of theorems, and they're really, really handy, and they both go together. Notice the first one is the base angles theorem. So it basically tells us, knowing we have an isosceles triangle, we know that the two sides are congruent. So if we know that, then we also know then that, according to this theorem, that the base angles are congruent. So in this case, angle B and angle C are congruent. So you can see that they marked the sides, and now we then can say that the angles are congruent because of this theorem. So the converse, which remember the converse just gives you the same information but in reverse. So this time we know that the base angles are congruent. Angle B and angle C are congruent, which then tells us that those sides opposite, which aka are the legs, are congruent. So again, in both of these cases, what they gave us is marked in black, and the information that we gained from the theorems, I went ahead and marked in orange. So what does this mean? This means that the base angles and the legs, both pairs are congruent always. They come together. Okay? So corollaries. Remember, we get that bonus information from some theorems. So a corollary to the base angles theorem says that if a triangle is equilateral, then it is equiangular. We actually already talked about that before. We mentioned that equilateral and equiangular triangles, they always come as a pair. So the corollary to the converse of the base angles, again, says the same thing in reverse. If it's equiangular, then it's equilateral. So again, equiangular, equilateral, those always come together as a pair. And just as a reminder, we talked last Monday? Yeah, when we did 5.1 notes, we talked about there are 180 degrees in a triangle. So if we have an equilateral and equiangular triangle, we've got 180 to be divided evenly between the three, which means they're all going to measure 60 degrees. Okay, so let's do some practice with this information. 1 through 4 say complete the statement and state which theorem you used. So looking at number 1, it says if NJ is congruent to NM, so that would be, actually I think I'm going to use pencil just in case I need to erase some of this. So if these guys are congruent, remember you can kind of flip your paper around because we like it when our vertex angle is at the top. These would be our legs, which means these guys are our base angles in this case. So, flipping it back around, that would tell me then that angle J is congruent to angle M. Okay, which theorem is that? Well, hold on, I have the theorems over here. Let's look at those again. Remember, the base angles tells us the sides first, and that's what we were given, so that's what we used, the base angles theorem. So it's always pretty much going to either be the base angles theorem or the base angles converse theorem. Okay, so number 2 says if LM is congruent to LN. So again, if we kind of look at this, these are the two that I just marked. If I kind of flip it around so that my legs are, my vertex angle then would be this guy. So that would tell me then that angle M is congruent to this angle N, so we got to name it a little bit better. How about LNM? So angle LNM is congruent to a regular angle M. And that was also the base angles theorem because, again, it gave us the sides, and the information that we gained were that those base angles were congruent. Okay, now this time they're giving us a pair of angles, so the first two gave us sides, and we used the base angles theorem. So now that we're given angles, we're going to be using that base angles converse theorem. So NKM, yeah, let me go ahead and erase this stuff really quick so we can start with a fresh slate. Okay, sorry. All right, so what do we got here? NKM. NKM is this angle, and NMK is that angle. So again, if I wanted to flip my picture around, I'm looking at this triangle right here. So if these are my base angles, then my legs would be these guys, and those are the ones that are congruent, NM and NK. So NM and NK. And again, that's the converse to the base angles theorem. Okay, and then finally on this page, LJN. LJN is this angle, is congruent to LNJ. LNJ. That's this guy. So if those are my base angles, then LJ and LN would be my legs here. LJ, LN, and we know then, based on our converse to the base angles theorem, that those guys are congruent. All right, cool. So remember, feel free to pause, replay, whatever you need to do to make sure you got this going on. Okay, so now if we look at number 5 and 6, it says find the value of x. So looking at number 5, you can see that these three angles are marked congruent. That was one of our corollaries. Remember the corollary to the converse of the base angles theorem says if a triangle is equiangular, then it is equilateral. And you almost don't even really necessarily need to kind of pay attention to what theorem it is. You just need to know if the angles are all congruent, then the sides are all congruent. So in this case, I want to find x. Well, x is a side length, and all the sides are 31. So x equals 31. Okay, looking at number 6, we know the opposite. We can see it's equilateral. They're not marked congruent, but they're all labeled 12, which means that all the angles are congruent. And we also talked that if we have an equiangular triangle, we know that every angle is 60 degrees. So this 2x is going to equal 60. So if I set 2x equal to 60, then we know that x is 30. Okay? All right, so finally number 7 and 8 kind of tie it all together. We've got some isosceles and equilateral triangles in here together. So looking at number 7, we can see that we've got these three marked the same, okay, which means it's an equilateral triangle. So if this is y minus 25, then this is y minus 25, and this side is y minus 25. And then also you can see that these two angles are marked congruent. So in this smaller triangle here, if the angles are congruent, then we know that those legs are congruent. So this one already has a marking, which means I need to mark this side the same way. So then that tells me that the x and the y minus 25, these guys are the same. Okay? So now also we can see that those two angles are marked congruent. And they are based off of, well, hold on. Let me back up. What I really wanted to say first was that we know that these guys are all 60. 60, 60, 60. Okay, so knowing that this is 60, and we can see that we have this right angle here. So if this guy's 60, 90 minus 60 leaves 30 left over for that guy. Okay, so now if I take 180 minus 30, I'm at 150, and I have 150 degrees left to be divided evenly between those two guys. So if I cut 150 in half, I'm at 75 degrees. So that means this is 75 and this is 75 degrees. So basically I just found that y is equal to 75, okay? Okay, so now knowing that y is 75, I can take that y being 75 and plug it in here. So 75 minus 25 tells me that each of these sides are 50. And remember, one of those sides is just x alone. So x would also then be 50. So let's back up here because I kind of just went a little, whoa. So we started and we said, okay, equilateral sides means all of these are equiangular. Knowing that they're all 60, you can see over here that this whole thing is a right angle. So if this part is 60, 90 minus 60, I should write that down, is 30. So that means I have 30 degrees left here. Now looking in this little triangle, I know that these two base angles are marked congruent, which means these two legs are congruent as well. So knowing that I've used 30 out of my 180, I have 150 degrees left to be split evenly between those two. So 150 divided by 2 is 75. So that helps me figure out what y is. And then knowing y is 75, I can plug that in and figure out then that x is 50. Okay, so I better hurry up because the bell just rang. Okay, looking at number 8, again, we've got an equilateral triangle here. We've got an isosceles triangle there. Remember, we know these are all 60. I don't know if that's going to help us yet or not, but I'm just going to mark them congruent for this part. Here, I know that these are congruent, so I'm going to mark them a little bit differently because I just marked the 60-degree angles, and I don't know that they're really the same as each other. Okay, so let's start with x because that seems like a simple one. If this is 40 and all three add up to 180, 180 minus 40 leaves me 140 degrees left to be split evenly between those two. So if I take 140 divided by 2, I get 70 degrees. So then I know that x is going to be 70. Okay, so now that I know x is 70, I can look and see that y over here, these are the two things that have y in them, but this one also has x. So if I plug that x in, 70 minus y, now I have just y. So again, knowing these are both sides that are marked congruent, I know that they're equal to each other. So I can set up an equation, 2y plus 10 is going to equal 70 minus y. So you know me, I like to get my y's alone first, so I'm going to add this y over and have 3y plus 10 equals 70. So when I subtract the 10 over, I get 3y equals 60. Oh gosh, I'm having a hard time here because I need another hand. So when I divide, I'm going to get y equals 20. And that's all that I needed was x and y. So I am done. So now that you have this, you can work on homework checks or do some practice, whatever you need to do, or rewatch it. It was pretty brief. So have a great day and a great weekend and get some work done.